First type of expression when you see that needs to apply integration by parts is if one of the two functions cannot be integrated, then integrate the one that's integrable. So you look at this x cubed as well as ln x. Oh, ln x cannot be integrated. Ln x can only be differentiated. Now I like to use this table where this is u, this is v, this is u prime, this is v prime. Okay, so some of you may find this table easy for you to use, as well as I like to write down my integration by part technique at the top, which is the integral of u v prime is equals to uv minus the integral of u prime v. Okay, so whenever I know I'm going to do by parts, I'm going to write this here. Okay, ln x can only be differentiated, so I'm going to choose ln x as my u. Okay, differentiate ln x, I'm going to get 1 over x. The other expression will be my v prime. So x cubed is going to be my v prime. I integrate x cubed, I'm going to get x power 4 over 4. So all I need to do now is to apply this into the question. X cubed ln x dx is going to be uv. So I'm just going to pick uv, x to the power of 4 over 4 ln x minus the integral of u prime v, u prime 1 over x, v, x to the power of 4 over 4 dx. Okay, the next thing I got to do is to just simplify it. I'm going to get x power 4 over 4 ln x minus the integral of, constants can put it outside of the integral. Okay, x to the power of 4 divided by x, that's x to the power of 3 dx. And your final answer is going to be x to the power of 4 over 4 ln x minus 1 over 4 x power 4 over 4. I integrate x cubed. Factorize to make it nice, x to the power of 4 over 4, big bracket, ln x minus 1 over 4 plus c, and that is how you apply the integration by parts if only one of them is integrable. Okay, just now I also talked about using LIATE. Okay, if you look at your right, these are what the meaning, which alphabet stands for. So I know that this is algebraic and this is inverse. So I comes before A over here using LIATE. That's where I choose him to be my u and he will be v prime. If not, you can just use logic. Can you integrate tangent inverse x? You can't. You can only differentiate. So that's why tangent inverse x is going to be my u and x is going to be my v prime. Differentiate this, I get 1 over 1 plus x squared. Integrate x, I'm going to get x squared over 2. All I need to do now is to apply it into my integration by parts formula, which is derived from the product rule. Okay, if you can't remember your formula, you can derive it from your product rule yourself. uv x squared over 2 multiplied by inverse tangent x, and now we're just going to keep it there, minus the integral of u prime v, 1 over 1 plus x squared times v, which is x squared over 2. Okay, this part is going to be a bit tricky. So this is u prime, this is v prime, dx. Keep the x squared over 2 inverse tangent x minus this guy, this expression. I'm going to take out half. I'm going to left with x squared over 1 plus x squared. Very simply, there's no way you can integrate this right now. All you need to do is any expression that you see where the power of the numerator is greater or even equal. In this case, the power of the numerator is equals to the power of the denominator. Just do long division, and after you did long division, you are going to get 1 minus 1 over 1 plus x squared dx. Okay, do long division for this, you're going to get 1 minus 1 plus x squared for this. If you wonder how I do it so fast, I just plus 1 minus 1 over here. This is going to give me my 1. Okay, and then this will be minus 1 over 1 plus x squared. If you understand how I use this zero-sum way to get the quotient plus remainder over divisor, that's good for you. If not, just use your long division to get this as a result. So with this, I can see, this bracket just, I keep on writing over here, minus half, integrate 1 x. Integrate 1 over 1 plus x squared. If this doesn't come immediate to your mind, means your integration technique is not so strong enough. Please practice more on that. Okay, plus c, and all you need to do is to expand the whole expression to make it nice, and then that would be your answer. So this is the first type of integration by parts, is to integrate the only one that is integrable or differentiate the only one that can be differentiated in the expression.